Okay, 2016 higher level question 1. We have, even from looking at the sketch, we can see it's going to be a flat roof. Let's read to the question and find the important words. A front porch with a flat roof projects 1.5 meters from the external wall of a house as shown. The roof of the porch is insulated and is covered with layers of bituminous felt on plywood decking on 200mm by 40mm roof joists. Insulated plasterboard is fixed to the underneath of the roof joists. The external wall of the porch and of the house is 400mm. Is a 400mm wall of concrete block construction with a full fill insulated cavity. The window of the porch is triple glazed and a thermally broken wooden frame. To a scale of 1 to 5, draw a vertical section through the porch, showing the external wall, the flat roof, the window of the porch. Show the typical construction details from a level 300mm below the fixed frame of the porch window, through the walls, the window head, the lintels, the flat roof, to a level 400mm above the abutment of the flat roof and the front of the house. Include 4 typical dimensions. And part B, show on your drawing the design detailing to prevent the ingress of water at the junction of the flat roof and the main wall of the house, so the abutment of the house. So quite a lot of key words to try and get your head around, but basically if you were to look at the sketch, they want us to go 300mm below the window here, up through the wall, the eaves of that flat roof, across here and up 400mm above there. So our detail is going to look something like that. Looking at some of the words, underline some of the important parts. The front porch of a wall projects 1.5 meters out. That's going to be helpful. 1.5 meters out from the external wall of a house. So there's the external wall of the house. That's the front porch. So from there to there is 1.5 meters. So, the roof of the porch is insulated and is covered with layers of bituminous felt on plywood decking on 200mm by 40mm roof joists. I'll look at a diagram in a second to kind of go through those parts. Insulated plasterboard is fixed to the underneath of the roof joists. The external wall of the porch and of the house is a 400mm wall of concrete block construction. So it's a 400mm cavity wall basically. So it's quite a wide cavity we're going to have on that, with a full fill insulated cavity. So there's full fill insulation there. The window of the porch is triple glazed with a thermally broken frame, so something that we're well used to doing at this stage. To a scale of 1 to 5, that's very important. Draw a vertical section through the porch showing the external wall, the flat roof, the window of the porch. Show the typical construction details from a level 300mm below the fixed frame of the porch window, through the wall, the window head, lintels, flat roof, to a level 400mm above the abutment. So 300 below here, 400 above there. Include 4 typical dimensions. That doesn't mean 4 labels. That means 4 of your labels have to have dimensions. All the rest of them have to just be labeled. And we'll go from there. It's 1 to 5, so it's going to be quite big. So we need to make sure that we use as much of the page, or be smart about where we set up on the page. All right. So let's have a look at setting that up. How we will go about the order of drawing that up. Here's my page. And the bottom left corner of my page is there. I'm going to start low and to the left, but just make sure I leave a bit of room over there for a bit of a gutter and stuff to stick out. And I'm going to just draw a wall first of all, a light wall. So the wall, it said, was 400mm cavity wall. Lightly first, just to help me mark out my positions. Draw a line for the first side of the wall. 100mm wall. It's quite a wide cavity now. It says 400mm wall, so 100mm will be a block, the external leaf. 100mm will be the internal leaf, and you've got a 200mm cavity. I'm going to just draw that up lightly, up about that height for the moment. Now I'm going to put a window here in a second. It's said to go 300mm below the fixed frame for the window. So I'm going to measure up 300. Obviously you must divide that by 5. And I'm going to draw a line across there, and that's actually where my wall is going to start. I'll get my rubber. About those bits. The window is actually going to go on this space here. Just so you're clear, again, it's going to look quite big when you draw this out. That's going to be 20mm when scaled down. That's going to be 40mm when scaled down, and that's going to be 20mm when scaled down. So external leaf, cavity, internal leaf. Now when you've got such a wide cavity, it's always good to put maybe a cavity closer across there. Cavity closer is just a bit of compressed solid insulation. That's often done just to block that. Go maybe 50mm up for that. Alright, now it says a triple glazed window with a thermally broken frame is fixed in here. It does not mention any sizes of a window frame, so we'll start at this point and we'll do our usual maybe 70 by 150. That'll bring us to about halfway across the cavity. So we'll go about there. Alright, measure in your approximately 5mm, whatever, an even space there. Go down about halfway through it and extend that down. If you want to add a little design of an angle to the corner of those, by all means do. We have that there. Now the window is going to come down here. Again, like I said before, around a millimeter or two thick for each frame, but you know, examiner will not be checking too much detail of that, as long as it looks okay. And there's your triple glazing of the window. It's a thermally broken window frame, so make sure you add some insulation in there in the middle of the frame. Alright, again you can see the cavity closed there because if not there'll be a big gap in that. Now, next we're going to go on to the eaves area of this flat roof. It's a flat roof, as we are all aware and clear. Because of space on the page, it's good just to maybe go up only one block. You know, it doesn't mention how high up to go, so usually you have an option there, but just for the sake of space, we'll go up only one block. When it comes to the eaves detail of a flat roof, the joist rests on top of the wall, and a wall plate is actually built back down into there, so they would use a smaller block, then put your wall plate on it, and that works out at an even space there. Alright, and the joist, I'll just extend a line out there. All light work to start me off. Joist is going to go all the way across. The size of the joist is specified in the question. It says there it is 200 by 40mm joists. So the joists are going across there are going to be 200mm high. So 200 divided by 5. Go up there. That'll work out 40. And draw that line across there. How far out does this go here? You can decide yourself. Again, you know, that's just within reason. Roughly out about that far for your fascia and your soffit. And that's the position of our joist. Now, when it comes to a flat roof, I probably should have explained this earlier, but we'll go through the two main types of flat roof. In your books, you've got a cold deck flat roof and you've got a warm deck flat roof. The warm deck flat roof is called warm deck because it's got insulation on top. That means the top of it's going to be warm, which is going to be less chance of condensation because that surface is warm. With this one here, it's called a cold deck. It's a bit more old-fashioned. The top of that is always cold, and that means condensation is more likely to form on that, which can be a problem. Ventilation is important for that to try and help that from happening. The question there, you can draw either of those flat roofs to a point, but the question did specify that the felt, so this red line here, that felt that goes on top of the flat roof, it's resting on plywood. So your plywood is there. So the roof we're going to do, we're going to put our insulation in between the joists, and then we're going to have the felt resting on top of our plywood, which I'll show you in a moment. But you have a choice of either of those within reason. The one thing I forgot to show as well is this piece of wood here is called the fairing piece. That's what gives us a flat roof. As we all know, it's not fully flat. It's got a slight slope on it. And this piece of wood called the fairing piece, which rests on the joist, is what gives us that slight angle. It can't be completely flat, or else puddles and pools of water will end up resting on top of it. So on top of the joist, next we're going to draw our fairing piece. Again, the fairing piece size can vary, so go up there maybe around 10 millimeters and project off at an angle. Set up your set square at the slightest angle, around maybe 10 degrees or less than 10 degrees even, and go off at a little angle there for your fairing piece. On top of the fairing piece, we have a sheet of plywood or OSB, which just covers all that up. And then on top of that, you have your bituminous felt, which is that black felt material that you see on top of flat roofs, which helps to weatherproof the roof. So get a layer of bituminous felt on top of that. I'll just go, before I go to the abutment, I'll just go and do up our fascia and soffit. So just come out there 25 millimeters, come down a bit lower here, you've got your fascia. Come across there, you have your soffit. Don't forget to draw in a gutter. Again, you can variation on the size there with your gutter. And now I'm going to go over, I forgot to, we've got full fill cavity insulation here, so the whole cavity is filled with insulation. Make sure and get that in. You can put a cavity closure on top of that if you want as well. That's optional. And over to the abutment. Now, first of all, the question tells us that it sticks at 1.5 meters. So if you're wondering how far across here do I go for the external wall, from here we measure across 1.5 meters. That's 1500 millimeters. You scale that down and you get your wall. Just for the sake of space on the sketch, I'm going to say that it's there. Alright, draw your cavity wall. Again, you should have the full cavity wall drawn in there. I've run out of space, but I wanted to show you the abutment area here, how we're going to make that look. So to help the joist stay fixed to the wall here, a wall plate is fixed to the wall, so that piece of wood there it goes along that way. It's nailed into the wall, and that allows us to fix this joist into this here using joist hangers, as they're called, but that just sits into place like that. The fairing piece runs all the way to the end, your plywood runs all the way to the end, and your bituminous felt runs all the way to the end. That felt, to help the ingress of, prevent the ingress of water, which is mentioned, that felt runs up the side of the wall like that. Alright, now the next block above the roof, let's say it's there, we have what's called lead flashing, which I've shown before, and the lead flashing is fixed in to that joint in the block, and it comes down and it wraps down over the felt. So between the felt coming up there and the flashing wrapping down over it like that, water cannot get in to that area there, so that helps avoid that problem there. You would also have some DPC which would run up along there as well, across and up over to the next side of the wall, which you'll see in the solution shortly. You can draw on a few blocks there. It doesn't say how far to go down here with the wall. It doesn't say whether you can go in, so maybe just go another block or two down further and you'll be fine on that. It says it's an insulated roof, so as we said, they said the felt is rest on top of the plywood, so we can't put our insulation between those because the question does say that's resting on there. So we'll put our insulation in between the joists. So we'll run that all the way along there neatly, all the way to the end. And the question does also specify that there is insulated plasterboard fixed to the underside of the ceiling. That's the ceiling up there, the insulated plasterboard, 50 mil for the plasterboard, and there's your bit of, 50 mil for the insulation. There's your bit of plasterboard that's fixed to it, and that allows you to plaster the ceiling there then, and that's also a layer of insulation, so there's plenty of insulation on that roof. At that point, it'll be just a matter of going and getting everything labelled up and tidying up all your pen work and whatever else you have to do. I'll just show you the full solution there now, a bit neater. That's what we should have in the end. So you can see there the window, triple glazed unit, thermally broken frame, the wall. You can see that the wall plate is resting back down into a block, so to use a smaller block there. Lintels, I actually forgot to mention lintels. Don't forget your lintels there. That's your insulated plasterboard. I have the full wall here now. You can see, make sure you get that full wall, and I just run out of space in my sketch. There's the DPC running over there. The red pen is the lead flashing. The black is the bituminous felt. You can see the little angle on my fairing piece, and there's the eaves area here, so the fascia and the soffit. Let's show the full solution there and work your way through that question.